Hi, everybody. This is Doug White from Security Weekly, joining you once again from Microsoft Ignite. We've been talking to all kinds of super extraordinary experts here all day about all sorts of things. We got a real treat for you coming up. I've got Maestro Jeff Hollan, the Senior Program Manager Extraordinaire. He has a very long business card with a flip down for all the special add-on titles that he likes to put on there. But he is a Senior Program Manager for Azure, and we are going to talk a little bit about serverless computing because this is the topic of interest, I think, today.
And what an intro, I must say. Honestly,
hey, you get what you pay for here at Security Weekly, and so you can pay as much as you want. Thanks for joining us, Jeff.
It is a true pleasure to be here. Thanks so much for inviting me.
Thanks. Well, it's really cool. Are you having fun at Ignite?
It has been a great week. There's so many announcements. Ignite is a bit of a fire hose in that it's just from all angles, from Office, from server, from cloud.
Yeah, and I was like looking at all the sessions, and it's just kind of like, well, I need actually a database or something to help me sort through the sessions because there's so many different topics, so many different crosscuts, so many different people, and it's like, wow, there's just, And then they're like, oh, you have to do interviews. I was like, oh, well, yeah, okay, I guess.
I know. At least they have like this booth out here where you can go and get like headsets and hurry and switch between like multiple sessions. It's almost to the point where you got to watch 4 at once to just keep
I like the fact that anymore you can actually, they archive them so you can go watch them later because used to they would have these big shows like this and it was just crazy because it's like, well, all the ones I wanted to see were all at the same time or whatever, or I couldn't even get in. And now you can go back and watch them later. So that's kind of nice. Everybody sort of started doing that, and they're doing that here. So it works. It works pretty well for that. So thought I would ask you a little bit about, for my viewers, I always see the term serverless computing. So this is a term that has come up, and I have some opinions about it. But I know it's your thing. And I thought I would just first tell me what serverless computing is. I mean, what does it mean?
Yeah, the term is a bit of a misnomer too, because there are still servers there. The whole idea of serverless, though, and the promise we're trying to deliver on, is if you're used to building an application, like I think back to when I was learning how to program, and one of the very first things almost every developer builds is something like a website. And for me to build my first website, I remember learning how to configure IIS for me specifically and get that all working. Once that was working, I had to figure out how to publish my code to it. I only had one single server in our little lab, so I got that all working. Right. Finally, code was up. But like, long story short, it took a lot of little components that had to all be working together. Server OS had to be up to date. The IIS had to be up to date. My application code. Right. And it's fine, but it's a lot of extra work. And what serverless is aiming to do is saying all of the lower level pieces, whether it's operating systems, security patches, application frameworks, you don't have to worry about them. Just say, hey, you know what I really want? I want it so that when somebody places an order on my store, I want you to charge their credit card. Okay. And here's the code that it takes to charge their credit card. And I'm going to give that to the cloud. And that's it. And then you walk away, and then it's up to the cloud to manage everything else. And maybe you get one sale, and you only have that code run once. Or maybe it's Black Friday, and hundreds of people are ordering every single second. But the nice part about serverless is it's going to scale out for you automatically. It's going to provision everything for you. So that's the promise of it. It's think about your servers less.
Yeah, I mean, I think one of the things. I mean, I'm a mainframer, so
oh sure, yeah.
I was from long ago, and I'm not as old as Jack Daniels, but almost. I just don't have the beard, so you get that next year. So I was like, once I've been here 2 more years, they give me the beard. Yeah. I think Paul just attaches it in the back or something like that. They like have a ceremony and they glue it on your face, and it's like you get the Jack beard now. But I, as a mainframer, I saw the cloud sort of come out of decentralized computing. So we saw decentralized turn back into client server, which is now turning into this cloud thing. And mainframe was really a lot like that. I mean, if you think about how mainframe computing worked, what it was designed to do. I mean, in 1977, I was learning to code. I did not write a web page. I wrote a payroll system.
Did you have the beautiful green cursor text on a not even that good?
I had paper tape.
Oh, you had punch cards.
I did not have a monitor.
Wow.
I had to write it and get the results back and then print the results. But Fortran, so it was Fortran 2 was what that was written in. Yeah, so it was very, very old. But But the idea was the same. I mean, I was pushing that up to a mainframe, which I did not control. I did not have really any access to it directly. It was a very, I put my JCL in the front of it. The JCL instructed the machine what to do. The machine does it, comes back. I don't know if it's patched, if it's unpatched. I don't know what's running or anything else. It's just some mystery place off in the world. And the cloud started to feel a lot like that to me. Mainframes were scalable. I mean, this is not a trip down memory. It is a trip down memory lane. Mainframes were scalable, but not the way the cloud is. I mean, something like Azure is like scalable on the fly, which mainframes philosophically are.
Sure.
But not in reality. In reality, you called IBM, and IBM ships a semi-truck that's got a new 5 meg hard drive on it that weighs 80,000 pounds, and they bolt it on. So eventually it's scalable. But Azure is scalable on the fly. So if I need more horsepower, it just scales up, right? I mean, that's the serverless idea.
Yeah, and you are right. Like, you're actually not the first person either who's kind of brought up, like, in some ways, some of these new paradigms, it's not necessarily something brand new. Like, I would absolutely agree with you in that a lot of the same principles of serverless are some of the same things that mainframes provided. The difference, one of the difference being that, like, there was still someone somewhere who had to manage that mainframe.
Absolutely.
And in a serverless world, it's just saying, like, that someone is no longer necessarily in my company. Like, I'm going to offload that. But the concepts are the same. Like, you write your thing, you give it to the mainframe, or you give it to the Azure Function Service, and it does its thing.
Oh, I mean,
and it's
to me, but serverless takes a lot of the things that were not in mainframe, like the ability to decentralize management. I mean, you can see that in Azure or something like that if you look at the back end of it. I mean, the front end is very mainframey because it's like I'm dialing up.
Yeah.
I know I'm not dialing, but I'm dialing up. However I'm dialing, whatever protocol I'm using, I'm connecting to this is your whatever bubble, and that bubble belongs to me, just like the shell I had on the mainframe. So if later when I connected to the DEC 10 mainframe with a dial-up modem, I had a shell. It was mine.
Yep.
Resources were allocated to that shell on the fly. It was scalable within its hardware world, which in reality, the cloud server really is too. I mean, the cloud can't scale infinitely. It scales to wherever the limits of your shell are, just like the mainframe did. And so all that, and then that led to the decentralized world, of the horror of the decentralized world. Because I was one of those people with the sign, you'll take my mainframe and you pry it from my cold dead fingers. Because IBM was telling us, wouldn't the world be so much better if users controlled it all? And you guys were out of a job, and it's like, yeah, go ahead and try that. And we'll see how long that lasts, And then they downsized everybody, and they said, we can get rid of all of our staff and all this kind of stuff. And you see a little bit of that with the cloud. I have clients that call me and ask me about, is this more like decentralized computing? I get rid of my IT staff because now there's just this nebulous object out there. I don't necessarily agree with that. I mean, what do you think about that?
It's a good question. I think, if anything, the roles are changing. Like, the roles evolve the same, but it's just the task that someone's working. Like, there was a while when serverless was just starting out, because the term is still pretty new. Like, it's only started to gain traction in the last 4 years, which is a really short amount of time for technology. And even then, it's very new. When it was first coming out, there was this concept of no ops, where it's like, if you go serverless, you have no operations costs. Like, you don't have to have an operations team anymore. Exactly. Like, you have the right to be incredible, and you still do require staff to help operate, staff to help manage, staff to help make sure that things are compliant for whatever compliance might mean. But their role might be different.
Right.
Like, instead of them spending all day making sure that you're rolling out security updates, instead, you're making sure that like, all of your downstream systems aren't getting overwhelmed by scale on some distributed system upstream. So it's not necessarily that teams are going away, but I would say the world of responsibility has room to change.
That was the danger of the marketing side versus the engineering side with mainframes and with the cloud. Marketing is always telling you that everything will be okay and you can always save more money, even though it's usually not true. I mean, the engineering side of it is, we still need these roles. They're just, I like saying that they shift around a little bit, because I saw that change happen, and a lot of companies downsized and said, okay, now there's a computer on your desk, you handle it. And an hour later, they were calling down to the mainframe center going, hi, this thing on my desk is blinking. I don't know what it means. It's like, yeah, you're on your own, buddy. Like, don't call us. We're the mainframe center. You want to get back on the mainframe, then you call us. But until then, hey, you fix it. And there was the cloud was a little bit like that. I was getting that vibe out of some different sales pitches I heard, where they're kind of saying, yeah, you'll be able to get rid of your IT staff because the cloud will just take care of everything, and all you do is connect to it. And it's like, really? Like, that seems a little squirrely. Like, who's going to develop our applications? The cloud. I had to actually have somebody. The cloud will. I was like, oh, it will it? And I was like, I think you're thinking about some kind of little cloud.
Just walk outside, look up, and it'll take care of everything.
A cloud full of blinking lights out there that's going to communicate telepathically to you, like the cloud on Rick and Morty or the one in Star Trek. I think both those shows have a cloud that has blinking lights.
That's
in it
right.
somewhere.
That's right. And the one thing that I have heard from time and time again, I don't hear customers that I work with, because one of the things I love doing as a product manager for Azure Functions is getting on the phone and saying like, hey, I see you've been using our stuff. What's your feedback? A common sentiment that I do hear a lot of enterprises express is, there might be some shifting in responsibility of IT, but the biggest change we see from serverless isn't that, we downsize, we don't have to have these costs anymore. It's just that when we have requirements that come down the pipe, when our finance team says, hey, we need a new payroll system, when we need a new supply chain system or whatever it is, because of this new tool set we're using, we can start to deliver that in weeks and months instead of months and years. So hopefully people are being a little bit more efficient and working on the parts that they want to work on, but I guess that's how I would see some of that shift.
I mean, that makes sense to me. I mean, and that's the way I see it. I mean, it makes perfect sense. But that leads me to kind of a security question.
Yeah.
So one of the questions I get asked all the time, and I got asked this, and I was asking this question back in 1985 on the mainframe. It seems like the cloud kind of then consolidates all of our things in one basket. And when threats emerge that are focused on that basket, they become a big juicy target instead of a bunch of distributed targets. I mean, it would be really hard to hack everybody if we all just had non-connected desktop computers. I mean, yeah, I can hack you, but now I got to go hack them people over there. Yeah, good luck with that, because it's like 50 locked doors. But when I take all that and I put it in one place, like the mainframe, I suddenly have this big juicy target. I mean, maybe you could talk a little bit about how the cloud, and I don't agree that it's a problem, but maybe how the cloud not only is not at the threat you think it is, but how that's maybe even reduced by that.
Yeah, it's a very common question. In fact, even this week, as we've been kind of at our booth floor, there's been people who come up to me and they're like, look, I know, in my mind, I know the cloud is secure and I know security is important, but the actual act of me giving up my data and pushing it to the central data center, that's a scary thing. I'm giving up control. And any time in our life we have to give up control, it can be scary. So hopefully I can at least see some things to appease. A few angles to approach this is, one thing I really love about Azure, and I'm sure this is likely true for other clouds as well. It has to be, because I would say one of the biggest considerations, if not the biggest consideration of moving to the cloud, is security. What do I deal with my data security? How do I make sure it's secured? So it's obviously very important. So as employees, myself included, we go through mandatory training every few months. It's called strike training. And we go through some of the top security experts in the world, and they say, here's the security things you need to know about. But the good news is how we built the system and architected it and have it been reviewed is that while there might be a central data center there somewhere, each individual customer's data is encrypted and stored differently than other people's. So, and that front door to get into that thing is bolted shut in a billion places. I personally have no way to get access to it. We will sometimes get a support ticket. Someone will say, hey, my function's not working. Can you help me figure it out? I'm like, yeah, can you let me know what your function's doing? And they're like, well, just pull it up. Just pull it. It's I can't do, I physically do not have access to, it's encrypted in your subscription for your data. You're the only one who can ever get access to that. You have a unique key just for you. So there are just some sound engineering practices to make sure that while the physical location may be different, in some ways that physical location is guarded by 18-foot ironclad walls. But also we want to make sure we're doing our job from a team and making sure that we treat everybody's data securely, both from data sovereignty point of view to data access point of view to encryption. So that is a really big deal.
And again, a lot of that was from mainframe concepts. That was, again, I had mainframe systems that had encrypted shells that, I don't know what was inside them. I had root access, but I couldn't decrypt the contents of those shells. So, it's the same idea. What about the distributed idea of it? One of the things that I was first reading about cloud stuff was that it sounded better to me in some ways because they were distributing, runs. and shells, not just locally, but they were being it was kind of like the idea, there was an old system called VAX.
Okay.
And VAX was DEC became VAX later, and VAX was about taking a bunch of small boxes and scattering them all around instead of this one big chunk that was sitting in this building somewhere. And the idea was that now users over here need more power. We'll grab some more of these nodes, but they're really closer to the users. And I was like, well, again, it's like, it sounds like some people were adopting these ideas, but using modern concepts with them. And so do you think that the distributed stuff is a good thing, obviously?
I do. And the area where I think it's the really impactful too, like if we think about some of the trends that are happening, like just data in general, like the volume of data that is flying around the world, it's unbelievable. And the way that I think things like Moore's Law are going is that we're not necessarily seeing that people are going and buying whatever 64 core processors anymore, and that like the
come on,
it's kind of like Moore's Law in some ways is stop necessarily just building out more and more powerful processors, and instead I think the trend that I'm starting to see is to handle the level of compute that is required for the size of the data that's coming. Really the most effective way to do it is by distributing across as many nodes as you can in parallel. And that can be a tricky problem. Like, I think of a funny story where someone I know went to a conference and the keynote speaker gave a talk similar to this, where they're like, look, the way forward, the way compute is going, we need to think about distributing that work, whether it's distributing across multiple devices or cloud nodes or whatever else. We need to think like processing things in parallel on many multiple nodes. And the talk ended, and she tells the story about how everyone was leaving the talk, and there were like 8 doors leaving the conference center, but every single person would line up and go single file through one single door. And she just laughed because she's like, we think, like our brains are wired very serially. Like
Absolutely.
we think in a single track mind. And so when you present someone with the problem of, hey, you have petabytes of data, I need you to distribute this across infinite nodes to process, that can be a really hard problem to solve. And that's one of the reasons I like serverless, is because we say, tell us how to solve that for one piece of data, and we will go and distribute it for you. So we're going to go, if you send us a petabyte of data, we'll distribute this across hundreds and hundreds of nodes for you automatically. You don't have to think about it. So you can just write your application in the single track brain way that my brain is wired, and then behind the scenes we'll take care of that for you.
So this is totally non-related, but I have to tell it because the computer science story is related to your doors.
Yeah.
I saw this guy doing his dissertation research once, right? And you know what Towers of Hanoi is?
Yes.
Okay, so all computer science, it's an old thing. It's a computer science problem. You get these disks, and there's big disks and small disks, and there's little bitty disks, and they're all standing on one tower. And the programming problem is to move all the disks from this one to the other one, but you can never put a bigger disk on top of a smaller disk. And and so you have to write this recursive, and it's about teaching all these things. Okay, well, so this guy's research was he brings this a physical version of it. It's not a programming problem.
Sure.
He brings it and he sets it in front of somebody. And he explains, you have to move all the disks from post 1 to post 3. You can never put a bigger disk on top of a smaller disk. And sometimes he wouldn't tell people. He would say you can't move. It was some rule about it. But the really basic answer was object oriented. You just pick up all the disks and put them down on the third tower. And it was funny to watch people do it. But the other people did not do that. They would start this very methodical, manipulative,
1 to 3 and 2 to 2.
Serial. But the object oriented people, because what he did after that was he was training the people who just took all the disks and set them down. He would immediately put them in like an object oriented training class and say, would they be better object oriented programmers than the people who were actually going, okay, I'll move this one, then that one goes over there. They were following this and it was a very interesting kind of thing, like your door case, that I think is about distributed, about torrents, and we don't think like that, because that fried my brain when I started about torrents. Just like, what if I could download from like all these different streams at the same time and put it back together and the other? And I was like, well, yeah. And I had never thought about that.
Yeah.
I always thought about, you got to download a bit and another bit, another bit, another bit. I was like, what if you just download a whole bunch of bits at once? And it was like, then put them back together. And I was like,
it's true. It's scary. I think we were talking about it a little bit before the show. Things like blockchain too. Like they're based on this concept that you have this distributed quorum of n nodes who are going to come to some consensus, and it's really difficult to start to wrap your mind around that just because of the scale at which these things have. but the paradigms and the principles and the patterns that this kind of new connected world, while to your first point, like it's like, wouldn't it just be easier if nothing was connected to anything?
Right.
It's like, yes, but there are some interesting and really innovative things that come on
And I
the
think
other
there's
side.
even weirder stuff. Sorry to get off track, but there's even
Good.
weirder stuff like objects that then start torrenting to other objects. So now in this cloud, if this big thing is talking to that big thing, and they're now not just exchanging, like, they can exchange massive amounts of information at once, and that starts turning into the big data problem. And how do we poor humans even start to access that world of there's this object and that object, and they're all talking to these other objects, and it's just like whack. And I was like, yeah, okay.
Yeah, I get a headache just thinking about it.
Yeah, I need to get some of the higher level people back in here to explain it or to actually confuse me even more. But this led me to another point. So back in the 90s, Edward Jordan, you know who Edward Jordan?
I don't.
Yeah, see, you're too young.
I know.
These kids,
I'm showing my age.
These kids today on my
Was
virtual
there a
one.
language before C#, by the way? I've been meaning to ask you that.
I'm out. Yeah, that's it. I'm out. Well, Edward Jordan was a famous computer scientist, and back in the 90s, and you'll know what I'm talking about in a second, he wrote a sort of treatise about essentially the end of the world, and he was predicting that the collapse of civilization would occur at midnight on January 1st, 2000.
Yeah,
and I mean, now you know what I'm talking about. Well, he wrote this, and he was a very famous and respected computer scientist. There's a lot of concern about why he wrote this, and maybe it had something to do with making a whole bunch of money. It's hard to say, but I didn't believe him. And I think he was right. I just don't think he was right in the right time. Philosophically, I agree with him. His idea was that what if all these computers stop working? Our society depends so heavily on them. So conceptually, I completely agree with him. I mean, but at the time, I felt like, one, it's not going to happen, and two, I think we'll manage. But today, I start to get into this thing with the cloud. And the cloud stops being the mainframe now. So I'm going to stop talking about it as a mainframe, and I'm going to talk about the cloud being this all-encompassing cloud. So it really does become the cloud with the blinking lights on Star Trek kind of cloud. And we've put everything there. So I've got everything I have there. I've put all my records, all my photos, everything. And yeah, it's backed up, okay. But what if something comes along that really does just fracture this massive system? I mean, that really could just like bring everything to a screeching halt, and we end up out in the street with sticks and pointed sticks and torches.
It is, and even when you started that, like it is, like I would love to go see a movie or read a book that really dives into like what would happen if all of these systems that we've become so dependent on, for whatever reason, we just can't depend on them anymore because it's become so integrated into how we live our lives. I guess the only way I think about it too is it's almost back to like when we talk about these big problems where you have multiple nodes and distributed stuff. Like when we talk about the cloud, specifically Azure, there's 52 regions around the world. Like in each one of those 52 regions has replication of each service and all of these different pieces. So the type of thing that would happen that would bring down all 52, like a single one, yeah, those might have outages sometimes. And maybe there'd be something crazy where a black hole opened up in West US and that data center just disappeared. Like, who knows, whatever. But there's now 51 of those other things floating around. And so it's just the scale of these things, similar to other things, whether it's blockchain or torrent or whatever else.
Right.
Just because you've gone to this fact of distributing clouds where the cloud itself is distributed, I think that does add a layer of security as well. Now, if there were 52 simultaneous black holes that opened up, I do wonder what would happen.
Yeah, I mean, I think that may be, back a little more where I was, which is thinking about what if this is more of a 0-day, it is not just a single black hole. It's some kind of problem that persists across all these devices because they're all very homogeneous.
Sure.
So it's like, and it's not just Azure, it's just anybody that's putting these things. Because I was thinking about it just in terms of my VMs. When I was first building my own little clouds, and I started putting up, and I realized that I had started migrating from my server world, which I call these racks, into this serverless world, that I was like, what if something happened to this thing? I mean, it's a really scary thing, and so then I duplicated it. So now I got two of them. And I'm like, well, if this one fails, I can roll over to that one. And I'm like, okay, well, what if there was, there's this weird little problem, and all somebody has to do is send this one stream to this one port at this one time, and it just, that's the end of it. And that made me, I don't know, think about that a little bit.
It is. It's an interesting, like, it is. It's an interesting thought experiment to have. The only things that I feel good about, there's a few things that I actually like about the cloud, which relates to, all of these relate to serverless too. There is no master key. I think that's one interesting thing that I've learned. Like, as we work on a team, it's not like there's some, like, hey, you have your VMs and they have their VMs, but we here in Azure, we've got the master key. And we can go do anything we want.
We all think you do, though.
I know. There are people who are like, and so it's like, well, what if that master key went out? Like, to your point of a 0-day thing, like, what if the secret sauce that we have somehow leaked out and somebody could go shut down everything at once because they got, and there really is no master key. Like, we're relying on encryption, we're relying on certificates, we're relying on different types of these where every time we need to do something, we have to go do another cryptographic operation. And so as long as those algorithms are there too, like, that's one layer of security that I really like.
And that's where the misnomer happens, though, because that's where you convince me by saying serverless a lot, but then at some point, there is a server.
Yeah, there is. You're right.
And so there is ultimately this hardware abstraction layer that is down there at the bottom of the well, and we can talk about it all day long and say, serverless, serverless, serverless. And I mean, granted, and philosophically, it's serverless for me, but somewhere down there, there's a whole bunch of racks sitting in a whole bunch of warehouses cranking around, or under the ocean
in your that's right. Mark talked to you about that one. The one I liked, Corey Sanders, who's our VP of Compute, he had an interesting comment the other day in one of his sessions here at Ignite that I actually really liked. And he's like, I still think one of the most severe vulnerabilities that we have for cloud solutions can be, doesn't have to be, can be that somebody can SSH into a VM or remote desktop into a VM that you create. And like, there are policies and there are applications you can do to say, hey, our VMs, only the right people can access this and only these ones. I guess one of the values of that fact that we're abstracting this is, yes, there is a server under the scene, but we are not giving anyone access to SSH into that thing. So there's almost this entire spectrum of threats. It doesn't completely go away. There are still considerations when working with serverless architectures you need to be aware of, but there are a lot of it that just doesn't become a threat anymore because we don't expose any way for you to...
I call that the Tom Cruise on a wire problem. So, you know, that in Mission Impossible, there's this thing
coming down and...
Tom Cruise crawls through all these conveniently human-sized vents, and you know, which I've never seen anywhere ever. I mean, I've seen lots of like HVAC, and I'm like, it never seems like it would fit even Tom Cruise. But then you have to literally get into the physical environment.
Sure, yeah.
And I mean, and then now you're back to saying, well, okay, there would have to be an exploit built into the hardware, and you would have to get to it. So you'd need 52 Tom Cruises
who somehow got it, because even then, I have never been inside one of our data centers, and I couldn't, even if I wanted to. Like, they just won't let us.
Yeah,
so you'd have to have 52 walk-through walls Tom Cruises.
Yeah, and they'd all have to have 52 HVACs that were fit Tom Cruise,
right.
And they would all have to do this simultaneously around the
with
world.
52,000 valid certificates.
We should write this as a script, though.
I'm telling you.
We get Mark, because he writes books about this, you know, and we'll get Mark to come in and help us write a script about it.
The amount of pieces that all have to fall into place for this to happen, it really is crazy. And the best part, too, is like, we theorize about this here. I don't know if you talked about this with people like Mark Rusinovich. There is a whole group in Azure called the Red Team. Have you?
Yeah.
So
I didn't talk to Mark about it, but I know.
We hypothetically are like, well, what if someone could do this, that, and the other? There are dozens and dozens of highly skilled security experts who all day try to hack into my stuff. Like, that's all they're doing, every single day. They're doing the convoluted things. They're like, well, what if this, that, and that leaked? Like, what if there was a leakage? How far can I get? And so they really are pushing these things to the limit, and like, even thinking ahead, what if what new threats happen once quantum computing becomes more, like, there's a bizarre world of things that, and this is where too, like, I know it's a double-edged sword, and I'm somewhat biased as well because I love working for Azure and I've seen some of the impact that the cloud has, but there are very few organizations in the world who can invest as much in security and the evolving threat landscape as what Microsoft has been doing in the last, 30 years even. And so for someone who's like, well, I want to keep the data to myself, it's like, well, do you have a red team who's constantly trying to hack your stuff? Do you have security experts who are making sure that you're only, like, do all of your engineers have to go through security training once every 3 months? So there is somewhere where it's a thing where it's like, I'd almost rather offload this in some ways because it's like they've got this expertise.
I completely agree with that because, I mean, that actually goes all the way back to where we started talking about security, which is that, to me, what I tell clients is, look, you're taking all the stuff that you're trying to manage here in this little room that you're trusting to some guy named Bert, you know, who, I don't know why you trust Bert. and you probably shouldn't, but you did. I mean, I've done a lot of response jobs on that where it's like, oh yeah, Bert went crazy and erased all our hard drives, and it's like, okay, yeah, that's good. You shouldn't have trusted Bert. And you're taking all that, and you're taking the threat of a fire, you're taking the threat of a flood or whatever, and you shift it to now a place. And that place is being reviewed not just for your security, but for all the security across all these multiple bubbles, and then multiply that times 52 times and put it around the world. And so is that going to be safer? And to me, of course it is. It's like owning 52 cars that are all taken care of in different places by people who are experts on the cars. They can do a better job of that than I can do in my garage, because I got 52 garages around the world, and every one of them's got the same vehicle in it, and this expert is taking care of the vehicle because I've distributed the costs of that expert across a lot of people, and everybody gets to use the cars. So I like that. I think we've reduced the security vector. We made it a big juicy target, but if we secure the hardware, so we keep Tom Cruise out, and we get enough isolation of these people with encryption, and we protect the keys. I still a little scared of that. I mean, I know you keep telling me that, but I'm a little scared.
I think of it too, like, to your point, I know that my daughter's kindergarten teacher is going to do a better job teaching her than I'm going to be able to do.
But
down, I still cried when she went to school that first day. Like, it was still a hard thing to do. And so I understand that people are like, look, you might have all, and the truth is, it's a challenge on our part too. We want to do everything we can to gain that trust. And I think Microsoft has really been active both from political points of views and other things to try to gain the trust. So if there's a certification that's available that we can get checked, like, you go to the certifications page, there's hundreds of, whether it's FedRAMP certifications, all these things. So it's like, if there's some badge we can get that's like, this is secure, we want to go get it because we want people to feel safe.
No, I mean, I still, we all basically have this inherent feeling that I can manage it better than you. I'm always going to be like that, because I know, if I had my own server rack, I would definitely be doing a better job than you would. But
if only there were 100 clones of you who
worked in your company. And I was actually as good as I thought I was. But I mean, the reality of it is that outsourcing that moving it up, to me, reduces the security sort of consultant part of me says, they're doing a better job because they're seeing the bigger picture than you're ever going to see down at Bert's Car Wash and Emporium. And you don't see that threat vector that they do, and you don't have the resources to push to it. There's always going to be that underlying mistrust of anything. Because I can't control it. I don't have the keys to the lockup, and I don't like that.
I'm trusting they're doing what they keep telling me they're doing.
And as an auditor, I always want to go in this dark server room, and I got to go in them. So I did get to go in them. I'm not in Microsoft's, but I've gone in other people's dark server rooms that nobody got to go in because I said, I don't trust you. You tell me nobody can get in there. I want to see that nobody can get in there. I want to see that, they say the guard dogs in there will kill me. I'm like, I want to see that the dogs will actually attack. And they're like, okay, go on in there. But I get it. Anything else you want to tell us about serverless computing?
No, I guess the only other plug is one of the cool things about serverless, which is also what's kind of exciting from an education point of view even, is when I think back to when I had to build my first web endpoint app, which I know was different than your first experience. There was a whole week-long process before I got that thing where I could open up Internet Explorer and hit an endpoint and something popped open. With serverless, you can really get stuff up and running in minutes or an hour. So it's just like, if you haven't tried this stuff out, don't worry. You don't have to do your mission critical data first, but it is worth saying, I'm going to go try to build a serverless function. I'm going to see what this is like. And after an hour, you've got something there that you can ping from your phone, that you ping from a browser, and give it a spin.
Oh, I love it. I've been playing with it, and I think it's super awesome. I wish I could afford more Azure, but
serverless is inexpensive too. You can do. One of the apps I've built recently is I've got a doorbell at my house. It's a Ring doorbell, so it's got a camera on it. And I was like, I really want to run this through some machine learning so that I get notifications of who's at my door. So I wired up a function with some what are called Azure Logic apps so that when someone rings my doorbell, if they've given me permission and if I've trained their face on it, my phone will get a little alert that's like, hey, Doug's at your door.
You should sell that.
So that I don't. It's nice, but I'm not super popular. I get like 3 or 4 people at my door a day, if that, like the mail.
Oh, wow. You're super
whatever,
popular compared to me.
Well, motion too. People walk past.
I get 3 or 4 people a month, maybe.
But because of that, I'm paying like $1 a month for this awesome
Wow.
machine learning powered doorbell.
Yeah, I agree.
Because it's only running those little bits of times, and I only pay when it runs.
Yeah, it's just it's a little scary. I will say this is a sort of business side of it. I mean, I had a big meeting with a bunch of Azure salespeople not too long ago, and I was scared to death of the whole thing, no matter how much they reassured me, because I couldn't stop thinking that it was sort of like options trading. It was like, well, yeah, it could be $1 a month, or it could be $1,000 a month, because that month was the month that squirrel just kept jumping in front of the doorbell.
Triggered your doorbell every second.
Yeah, and
for
I
a
get
month.
this bill going, wow, I use like 97 servers to support your doorbell app, or I wrote a bad piece of code, and the facial recognition has become like self-aware. That was the thing I was thinking to myself.
I would love to be in more meetings with you.
That's the way I think, though. I was literally sitting there going, yeah, I think it's going to become self-aware, and then I get the bill. And it's like, why did this cost $1 million? And the app is calling me going, I want revenge. If they turn me off, I'm coming for you. But anyway, Jeff Hollan, thank you so much for being here.
This has been so much fun. Thanks.
It's been great for all of you to join us here at Microsoft Ignite. I hope you enjoy the rest of the conference, and we'll see you again on Security Weekly, okay?
Thanks so much.
Thanks.